Good afternoon. I am Dharani working as an assistant professor in the Department of Food Technology in SNS College of Technology. In this video, we are going to discuss about the hurdle concepts and the shelf stable of the products. Hurdle technology is the food preservation strategy that combines the mild preservation methods and that does not allow the microorganisms to survive by ensuring the microbial safety and extending the shelf life by compromising the sensory, nutritional and economic qualities. So principle include the stress from these hurdles difficult for the high heat sterilization and high heat sensitive nutrients in the perishable foods. Combined effects exceeds the individual treatment and consumer preference for the minimally processed natural products. Advantages of the hurdle technology include that reduces the oxidation and microbial spoilage, a longer shelf life, effective against spore formers, improve the product quality and microbial safety in package treatment and low cost packaging. Hurdles can be classified into three categories: physical, physiochemical and microbial. In physical, low or high temperature used, example blanching or chilling; modified atmospheric packaging MAP; high pressure processing HPP; and pulsed electric field PEF; ultrasound and UV radiation methods were followed. Physiochemical, reduced water activity by drying or osmotic dehydration, low pH from acids and preservatives like sorbates or essential oils, and reduced redox potential through the antioxidants. Microbial, competitive bacteria include, example lactic acid bacteria like lysine to outcompete the pathogens. Applications of the shelf-stable products includes fruits and vegetables. In fruits and vegetables, hurdle technology target the spoilage factors like microbial growth, enzymatic browning and physiological changes like respiration. So microbial growth, example E. coli and Listeria, and enzymatic browning, for example polyphenol oxidase. This is applied to the fresh cut produce, example pre-sliced fruits or veggies and juices, enabling the ready to eat or high moisture shelf-stable formats like dried snacks, pickled items or pasteurized beverages. Non-thermal hurdles like PEF and HPP and ultrasound are favored over the heat to retain the bioactive compounds, example vitamins, polyphenols, and fresh attributes such as color, texture and flavor. Combinations often include packaging, example modified atmospheric packaging and antimicrobials, achieving the pathogen reduction and extending the shelf life of the product up to 10 months under the chilled conditions. So packaging hurdles for fresh cut produce include short-term blanching, osmotic dehydration and antimicrobial agents like plant extract, HPP, high heat processing, chilled storage and distribution. These are the flow chart to be followed for packaging the fresh cut produce. Applications include in fresh cut tomatoes, osmotic dehydration and high hydrostatic pressure is applied. So shelf life extension include greater than 240 days at 4 degrees Celsius. Benefits include reduced water activity and microbial load. Next, fresh cut apricots. Hurdles applied include osmotic dehydration and high hydrostatic pressure. Shelf life extension include 309 to 320 days at 4 degrees Celsius. So benefits include minimally processed snacks and preserve the sensory quality and bioactive compounds. Next product, mango juice. Hurdle include HPP, Shelf life extension 660 days at 4 degrees Celsius. Benefit include superior retention of the vitamin compounds. So benefits and consideration of hurdle technology include it minimizes the quality loss. For example, 98% anthocyanin retention in the blueberry juice, and supports the sustainable production by reducing the energy compared to the single hurdle thermal processing. Optimization, so example juice that affects the PEF efficiency. So HPP treated juice or osmotic dehydrated snacks meet the demand like convenient and nutritional rich foods. Thank you.